Chapter 2, Section 4 is multiplying real numbers. And so we are reviewing what goes on when we multiply integers here, right? Positives and negatives. So the sign of a product. So I need two numbers, Mary.
4 and 8.
Okay, so she says 4 and 8. So 4 times 8 is?
32.
Good. And we could also say that negative 4 times negative 8 is?
Negative
32.
32.
It's still 32. Okay. So when we multiply factors with the same sign, we end up with what type of product? Positive product.
Or negative something.
So if I were to add some factors, let's say negative 4 times negative 8, you told me is positive. What if I add more negative factors? How many negative, what's the smallest number of negative factors we could add to that and still make a positive product? Wesley? 2, he says. So we could go negative 4 times negative 8 times negative 1 times negative 2, let's say. And now it ends up, we still have a positive product, and what is that product? Anybody? Say it.
64.
64. So when we have, how many factors need to be negative in order for you to, end up with a positive product? Say it, Bella. An even number, so we can add that to this as well. If we have 2 factors that are negative, or if we have a combination of even negative factors, we could have 4 negative factors, we could have 6, 8, 10, 12, 100 negative factors, and we would have a positive product if the operations were always multiplication, right? So when do we have a negative product? Using the same numbers that we have here, that Mary gave us, 4 and 8, how can I end up with a negative product? What would I have to do, Sophia? Good, so negative 4 times 8 is?
Negative 32.
And the other way everyone can say it is 4 times
Negative 8.
negative 8. So we can say that when we have factors with different signs, 2 factors with different signs, one's a positive, one's a negative. Max, what type of product do we get? Not this, but a negative. Good. A negative product. So thinking back on having an even number of factors gives us a positive product, then how do we get a negative product? We have an odd number of factors. So go ahead and try these samples and then come back and check your work. And there we go, 21, negative 24, and we end up with a positive 12. 2 negative factors, a positive 12. Okay? We're going to talk about a bunch of properties of multiplication today. The first is the commutative property. What does it mean to commute? What does it mean to commute, Mrs. Breen? Yes? There you go. So what does the commutative property of multiplication mean?
That you can move the numbers around, still get same answer.
You can move the factors and it doesn't change the product, right? Very good. It's about moving. Order doesn't change a product. Finish the rule. Sterling, and how do we show the commutative property with this rule? Very good. A times B equals B times A. Good. Associative property. Give me one word that's kind of a synonym for associative. A word that begins with G. It's all about, Christina? Very good. She says grouping. So the associative property says grouping factors differently doesn't change the product. So keep in mind the order is going to stay the same here. We're not commuting things, moving them. We are simply talking about how we group them. We have A times B grouped together, times C, or we could call that AB times C. And who can regroup? Who can show us how these may be regrouped to exhibit the associative property? Lindsay.
A parentheses B times,
Yes, you got it. B times C. Or it could be said A times BC. Says the same thing. Okay? Okay, the next one is the identity property. Keep in mind, we're talking properties of multiplication. So, Ray, tell me, give me a number, any number? 7. So if I am 7, what will I multiply myself by to maintain my identity? Very good, that's it. 7 times 1, right? If we multiply a number by 1, it leaves the same number. Multiply a number by 1 gives you the same number. So without even showing you the beginning of the rule, who can tell us the rule? Using A for your variable. Chris, give us the rule for the identity property of multiplication. A times 1 equals A. Very good. Where is my video? There it is. Okay, the next is on the next page. Here we go. The zero property of multiplication. The zero property of multiplication says that a number times 0 always equals 0. And so Casey, since you're so smart, you're going to tell us the rule then for this.
Okay.
Give us the rule.
A times 0
Equals
0.
Good job. A times 0 equals 0, not 8, right?
Right.
A times 0 equals 0. Good job. -1 property of multiplication. What happens when we multiply any non-zero number by -1? If we multiply any non-zero number by -1, Anthony, what happens? Well, okay, what if I multiply -5 by -1?
Then it becomes positive.
So what can we say about multiplying any non-zero number by -1?
It can switch the sign.
It switches a sign or becomes the opposite, right? The opposite. A factor of -1 gives an opposite product. A times -1, can you finish that, Anthony? Equals, good job, -A. Excellent. Okay, and we have 3 other properties of multiplication. We have a lot, you have them all. Now, it's really wonderful to have them in one place. The closure property of multiplication. Think back to our discussion about the closure property of addition. Does anybody remember that? Give me an example of the closure property of addition. Come on, think hard. Hannah. If you add 2 numbers, it gives you some real number. So 1 plus 3 equals 4, and close the door on that, you know. It will always be true that 1 plus 3 equals 4. Close the door on that. So with multiplication, we could say that when you multiply 2 numbers, will you always get a real product? Who thinks you will? Who thinks you won't get a real product? No, you all think you will, and it's true. When you multiply 2 real numbers, you will get a real number. So, can you finish this rule? A times B equals
C.
C. We would use C to represent a different number. Even though A times B could also equal AB, that's not really a unique different number, is it? So we'll say C, a unique number. And the distributive property, we actually see more than one operation taking place. Bless you. In the distributive property, right? If we were going to write the distributive property in the form of a rule, beginning with this, what would we say next? A plus B what? Chris? Good, times C. There it is. So we have addition and multiplication going on, right? This also is true when you see subtraction. So we could have A times B minus c, right? So, distributive property involves two operations. Addition and multiplication across that addition, or subtraction with multiplication across it. And finally, the inverse property. So what is the inverse of multiplication? Division, right? So what is the inverse? Here's another question. What is the inverse of like 3? The inverse of 3 is? Negative 3 is not the inverse, it's the opposite. The inverse of 3 is?
3.
What's underneath 3? 1. So the inverse of 3 over 1 is? 1 over 3, right. So if we take any number, a, and multiply it by its inverse, 1 over a, what do we get? A times 1 over a. A is just a over 1, isn't it? We end up getting what value every time?
1.
We get 1, right? We get a over a, or 1. So when we multiply inverses, a number and its inverse, we end up with a product of 1. Okay? Let's try a few examples. And I'm going to take some volunteers. So if you're at home, then try these and come back and check your work. So we have 3 halves y, or 3y over 2, and 8/10 times x. And I need another volunteer. And, okay, Chris. Okay, so Chris multiplied the first two factors together, giving him positive 0.5y. And then he multiplied that to negative 6, and he ends up with negative 3y. Very nice. And there you go.